What's up, math stars? Ms. Sorensen here with video 17, conditional probability. This is truly one of my favorite topics. I think you're going to really enjoy it as well. All right, here's a formula you need to get down. Conditional probability. For any two events, A and B, from a sample space with probability of A does not equal 0. This really doesn't matter, but it is part of the definition. The probability of something happening, and we're going to call this the probability of B given A. Okay, that's what this means. That symbol right here stands for given. The probability that B happens given A is equal to the number of B and A divided by the number of A. So before we really talk about what this means, can we look at kind of the pattern? Notice how we've got B and then A. And notice this also restated B and A in the same exact order. And then what I want you to notice is the denominator is the last thing here. It's kind of on the right side or at the end. Okay, so remember that format here. Why is conditional probability important? Well, it's important because we want to be able to limit our sample spaces down to certain types of people or types of things. So for example, if we found out that a lot of students were drinking in Manson, we would really want to narrow it down to, well, which types of people? What's the probability that you're drinking given that you're a freshman? What's the probability you're drinking given that you're a senior? So you can see how narrowing it down to a certain given sample space really helps you understand a probability better than a general one. So we're going to do this. We're going to say, what's the probability that you wash the dishes given that you're female? So you can see we're kind of limiting it to the females. We basically say given female. So who don't we care about? We actually don't care about the males at all. So what's the probability you wash the dishes given female? Well, from our formula, we know we want the number of washed dishes and female. Probability of washed dishes and female divided by the number of females. Okay, well, let's deal with the numerator here. What is the probability, or just the number really? Oopsie. What's the number of washed dishes and female? We're looking for both of those things. So washed dishes and female. Well, that would be this right here. 7 females wash the dishes. So that's the number of washed dishes and female. Okay, so that top number here is going to be 7 divided by, and what are the total number of females? Well, that's here where I want to circle that whole entire thing. Well, what's 7 plus 6? How many females do we have? We have 13. So that's our answer. So the answer to what's the probability you've washed dishes given female is 7 over 13. All right, let's try a different one. Sometimes we want to limit our sample space down to maybe the people that have done a certain thing. So for example, maybe we want the probability of male given that we know that they washed the dishes. Okay. Well, I kind of want to, instead of writing this out in words, I want to start circling the big thing and then the little thing. Well, we know our numerator is going to be male and wash dishes. Well, where's the male and wash dishes? That's right here. Okay, that and is both male and washes dishes. Divided by, so we know that's a 7 on the front, divided by our denominator is just going to be the people who wash the dishes. Well, who are the people that wash the dishes? These are the yeses. So that's going to be 7 plus 7 is 14, which is equal to 1/2. So to summarize this, our numerator is male and washed dishes, is going to be that small circle. Our denominator is going to be the big circle, the people who have washed dishes, which are the yeses, which is going to be 14. Okay, let's talk about olives. I dislike olives. I think they are absolutely disgusting. I cannot believe that anyone actually likes them. So if you're an olive liker, it's just amazing to me. All right, let's do this one. Probability that likes olives given male. Well, the first thing is likes olives and male. So that's 15. Divided by the total number of male. Well, that would be this. So we've got a 15 over 45, which is 1/3. Okay. The next one is, what's the probability of male given you dislike olives? Well, we have to first find our numerator, which is male and dislikes olives. So that's male and dislikes olives, divided by the total number of people that dislike olives. So in this case, that would be my big circle of 50. So that would be 3/5. All right, let's try another one. What's the probability you're female given you like olives? Well, first we circle the females that like olives. Here they are. So that's our numerator. Divided by the total number of people that like olives. Well, who likes olives? That's 25 people right there. And that reduces to 2/5. All right, another really fun thing that we do is I like to ask questions to the class, then I step outside and everyone answers. So I really would be asking you these questions, but let's go ahead and guess what the answers would be. So maybe I ask you, who has cheated on a test? And usually I leave the room and people answer. Let's say there's a yes here, a no here, a female, and a male. All right. And let's say we have 7 females in the room and 4 say yes, they've cheated, and 3 say no. And then let's say 6 males have cheated and 1 has not. Yikes, guys. And I say, what's the probability that you've cheated given you're female? Okay. Well, our numerator is going to be the cheated females, or the females that have cheated. So that's going to be 4. Divided by the total number of females, which in this case would be 7. There we go. Let's try another one. What's the probability that someone has cheated given that they're male? Well, where are the cheated students who have cheated that are male? That would be this number right here. So 6 divided by the total number of males, which in this case is 7. All right, last problem for this topic. Let's do the probability that you are female given that you have cheated. Okay, we need to find that small number first. That's a female that's cheated. So that's going to be 4. Divided by the total number of people that have cheated. So that would be someone saying yes. So that's out of 10. Okay, well, 4 out of 10 is going to reduce to 2 out of 5. And we are done. So that's conditional probability. You've got to use that formula that I already gave you. I hope you enjoyed it. It's one of my favorite topics. Thanks so much.